So here's another problem that involves industry, because we're talking about minimizing a cost by finding out the least amount of material. Usually whenever they're asking you for a problem that involves least amount of material, that means you're probably talking about a surface area. So this time we're working with a can. We're asked to design a 2,000 cubic centimeter can, which in math terms is right circular cylinder. And because of that, they give us the two formulas that we need to use along with that one. So in this case, you have a surface area for a can and a volume of a can that's given. Now why do they give us a volume? Because actually the 2,000 there, that's a volume also. We know that because you have centimeters cubed. Anytime you have a cubed measurement, that means it's going to be a volume. So we know that we can set 2,000 equal to this because that is the formula for volume that they give us. Now that's basically all that we know so far. We're not given any information about the surface area. However, we know that eventually we're going to have to take the derivative of that, and it'd be better to have only one variable in here. So because they give us this piece of information, that's going to allow us to solve for one of the variables. We can plug it into here, and that's going to allow us to have only one variable when we do the derivative. Now we can solve for either r or h, and h is going to be easier because we solve for r, we're going to have square roots, so it's going to be easier to deal with the h. So in this case, I'm going to solve for h, and I'm going to get 2,000 divided by pi r squared. Okay, so now that I have the h, what I can do is put that into this h here, and that's going to eliminate one of the variables. I'll have r only as the main variable. So I have 2 pi r squared plus 2 pi r, and then instead of the h, I'm going to put in this 2,000 divided by pi r squared. So I'd like to do a little simplifying with that. So I'm going to do 2 pi r squared plus, okay, now when I multiply this across, 2 times 2,000 is 4,000. The pi's are going to cancel. I'm going to end up with an r down below. So I'll have 4,000. And then I could write that over r, but instead I'm going to write it this way with a -1 power to make it easier when I do the derivative. It's already in the proper form to do the power rule. Okay, so now I'm ready to do s prime. I'm going to do, the 2 comes down, I have 4 pi r to the first power. Okay, and then this -1 comes down to be minus 4,000 r to -2. So that would be your first derivative. We want to set this equal to 0. Okay, so 4 pi r. Alright, now this will be minus 4,000 over r squared. And then when we move that over, 4,000 over r squared equals 4 pi r. And then this is going to be over 1. So then we're going to be doing some cross multiplying here is the easiest way to solve that one. Okay, so if we cross multiply, 4 pi r cubed equals 4,000. We're going to divide both sides by 4 pi right here, and you'll get r cubed equals 1,000 over pi. Now, when I do the cube root of both sides, cube root of top and bottom, that means that I'll get, let me bring that over to here. You're going to have your r is equal to cube root of 1,000 is 10, and then cube root of pi, that's not going to go into any nice number, but that's going to be your r. And if you wanted to get a decimal for it, you could, and that's going to be 6.82 centimeters, or you can use the exact one. They may ask for the exact one if you do the homework online, so that's the exact answer there. Now, we want to know the r, and we want to know the h as well. So let's come over here and we'll solve for the h. H, remember, was 2,000 over pi r squared. We want to put the r into here. That way we'll find the h. Okay, so let's do that. We put that in there, 2,000 pi, and then we have here 10 over cube root of pi, and then that's, don't forget to do the square there. Okay, so now when we do that part, we're going to square top and bottom on that. So let's do that first. 2,000, and then when we do that, that's going to be 10 squared is 100, so 100 pi. And the bottom, we're going to have we can write that as pi to the 1/3 if you want to there, because that's 1/3 squared actually would be 2/3, so 2/3 should be what you have there. 1/3 here, multiply a power by when you raise a power to another power, you got to multiply exponents, so it should be a 2/3 there. Now let's flip it. 2,000 over 1, and then you have pi to the 2/3 over 100 pi down below. When you simplify it, let me put the final answer over here. 2,000 over 100, you get 20. 2/3 minus 1 is going to give you 1/3. 1/3 will end up down here in the bottom because this is where the higher power is. And what is that going to be? That's a cube root of pi. Okay, and so then that's going to be about 13.66 centimeters. Do you notice the relationship between the two? As it turns out, it actually doesn't matter what results. You're always going to end up getting a relationship where the height has to actually be twice the radius. So that's always going to happen in this case. If you want to use the least amount of material, all you have to do is just make sure whatever the radius can actually be anything, and just make sure that whatever the height is, the height's got to be double the radius. And if you do that, that'll ensure that you'll get dimensions that are going to use the least amount of material in this case.